heat and temperature. Now we learned heat and temperature at primary 4. Some of you may have learned heat and temperature at primary 3, but in most schools you learn heat and temperature at primary 4. Okay, now heat is one of the bigger topics in PSLE science. Okay, and there are many concepts that you need to know. Okay, let's take a look at what you need to know under the topic of heat. Number one, you must be able to list the common sources of heat. Okay, what are the sources of heat? Number two, you must state that temperature of an object is a measurement of its degree of hotness. Okay, you must be able to understand what is temperature. You must be able to differentiate between heat and temperature. Now, many students, they confuse or they interchange between heat and temperature. Okay. Next, you must show an understanding that heat flows from a hotter to a colder object until both reach the same temperature. This is a very important concept, the concept of heat flow or the concept of heat transfer. So you must know that the heat flows from a hotter to a colder object until both reach the same temperature. Okay, next, you need to relate the change in temperature of an object to the gain or loss of heat by the object. Okay, you must relate the change in temperature of an object due to either the gain or the loss of heat. This is very, very important. Any question involving heat, there is a high chance that you need to include these terms, gain heat or loss heat. If not, marks will be deducted or you will not gain any marks. Next, you must be able to list some of the effects of heat gain or heat loss in our everyday life. Okay, for contraction and expansion of objects, as well as change in the state of matter. Okay, we will discuss more later what it means by contraction or expansion of object. Next, you must be able to identify good and bad conductors of heat. You must be able to identify good and bad conductors of heat. And you must be able to measure temperature using a thermometer or a data logger. Okay, a thermometer or data logger. All right. Next, what is heat? Heat is a form of energy, just like light. Light is a form of energy. It is not a matter. We know that matter has mass and occupies space, but heat has no mass and it does not occupy space. Okay? So things are known as sources of heat. Burning fuel such as wood and gas produces heat. The sun produces heat. Electrical appliances such as electrical irons, water heater and electrical ovens also are sources of heat. And the sun is our main source of heat. Our sun is the main source of heat. It keeps the earth and the living things on earth warm. Okay. Now, what is temperature? Temperature is how cold or hot something is. It's a measurement of how hot or cold something is. Now, temperature is measured in degrees Celsius. Temperature is measured in degrees Celsius. And this is the symbol of degrees Celsius, the unit for heat, temperature. Okay, a small zero here, followed by a C. Now, in some countries, they use a different unit of measurement. Like in America, they use degree Fahrenheit. So if you read some newspaper article or magazine articles, so do not worry. Just just like kilometers and miles. But in our area, Commonwealth country, we use the term, the unit degrees Celsius to measure temperature. Okay, so thermometer is a common tool to measure temperature. Now, in a common, this is a laboratory thermometer. So you have a liquid inside the bulb. So the level of liquid rises or falls according to the temperature changes. So when the temperature increases, the liquid will rise. Likewise, when the temperature decreases, the liquid will fall. And this liquid is usually either alcohol or mercury. Either alcohol thermometer or mercury. But nowadays, you don't see this very often. Right? Nowadays, they use electronic, or digital thermometer. Even in the laboratory, we use the data logger. Okay, using heat sensors. These are example of heat sensor and data logger. Okay, so you can see here, I think some of you may have used the data logger in school. All right, so you can see this is the heat probe. Okay, or when when you want to measure a temperature of something, you just insert the sensor. Okay, like this example here, this is capture data. Okay, and it you can either read the data from data logger itself, or you can input it into a computer and you can analyze the data using softwares. And this is the temperature and the heat sensor. Okay, so you can attach different number of sensors, okay, depending on your experiment objectives. Okay, and of course this data logger not only can measure temperature, okay, it can also measure sound, can measure heartbeat, can measure acidity, measure light. So you just need to change the probe or the sensor, okay, according to your the experiment that you want to conduct. Now, what is the difference between heat and temperature? Okay, let's take a look here at this experiment. So I will use two experiments to illustrate the difference between heat and temperature. Now let's look at beaker A. Now beaker A, the temperature is 60 degrees Celsius. Beaker B, the temperature is 30 degrees Celsius. So the amount of water is the same. So beaker A and B have the same amount of water, but the water in beaker A has a higher temperature than the water in beaker B. So to heat up the same amount of water to a higher temperature, more heat is needed. Thus, the water in beaker A has more heat than the water in beaker B. All right. Now, I repeat again. Now, because both amount of water is the same, okay, both water in beaker A and beaker B is the same, but in beaker A, the temperature is 60 degrees Celsius. In beaker B, the temperature is 30 degrees Celsius. You need more heat, okay, to increase the temperature of beaker A to 6. Okay, but in beaker B, the water is only 30 degrees Celsius. So we can say that the water in beaker A has more than the water in beaker B. Okay. Now let's take a look at next example. Then you can understand clearer the difference between heat and temperature. Let's take a look at another example. This is beaker C and beaker D. Now both beaker C and beaker D, the temperature is at 80 degrees Celsius. Okay, the temperature is the same, 80 degrees Celsius. Right? But there is more water in beaker C as compared to beaker D. There is more water in beaker C as compared to beaker D. Right? So the water in beaker C and D is at 80 degrees Celsius. However, more heat is in beaker C than in beaker D, since more heat is needed to warm up a greater amount of temperature. So you can see here the difference here. So even though in this example, the temperature is the same, but the amount of heat is different. Okay, why? Because in beaker C, there is more water. Okay, there is greater amount of water in beaker C compared to beaker D. So even though the temperature is the same, since beaker C has a larger volume of water, so you need more heat. Okay, you need more heat in beaker C than beaker D, such that both have the same temperature. Okay, understand the difference between heat and temperature? All right. Now, why do things become hot or cold? Why do things become hot or cold? So things become hotter when they gain heat. Things becomes hotter when it gains heat. Things become colder when they lose heat. Things become colder when they lose heat. Yeah. Just an example. Let's say you are having you are having a fever, for example. Now your body is warm, right? So when when your mom or someone touch your forehead, the hand becomes hot, right? Why the hand becomes hot? Because the hand gains heat from your hot body or hot forehead, right? Since your forehead is hot, okay, it loses heat, and the hand gains heat from the hot, okay, your hot body or hot forehead. Okay. Now another example. Let's say you buy a cup of coffee, hot coffee. So you leave it on the table. Now after some time, the water or the hot coffee becomes cold, right? Now what is the reason it becomes cold? Because the hot coffee loses heat. To where? To the surrounding. Okay. And another example, let's say you buy, a can of cold Coca-Cola. Again, if you leave it on the table, after about 1 hour, it becomes, it loses it. It doesn't become cold anymore, right? Now, what's the reason? Is it because it loses coldness? No. Okay, this is a misconception. It doesn't lose coldness, but it has gained heat. Okay, the cold Coca-Cola gains heat from the surrounding. That is why, okay, the temperature decreases. That is why it becomes warmer. Okay, not because that it loses coolness. So this is a common misconception. Now, what is the property of heat? Heat travels from a hotter place to a colder place until both places reach the same temperature. Heat travels from a hotter places or hotter object to a cooler object until both places reaches the same temperature. So you can see here example, right? Heat transfer, warm object, it will be transferred to a cooler object. Okay, why? Because the concept of heat transfer from region of higher temperature to region of lower temperature until both reach the same temperature, right? Now, why do things become hot or cold? The mug is gaining heat from the hot chocolate. This will cause temperature of the mug to rise. So if you have hot chocolate, so you can see here, this is hot chocolate. Now, when you hold the mug, all right, when you hold the mug, you feel hot, right? You feel hot. Why you feel hot? Because the mug here, okay, the chocolate loses heat to the mug, and the mug here gains heat from the hot chocolate. Another example, see the bowl of noodles here? The noodle is losing heat to the surrounding, which will cause the temperature of the noodles to fall. So if you are eating something, right? Let's say you buy, a bowl of noodles. So if you see after about 5 to 10 minutes, you can feel that it becomes, less hot. So it becomes, the temperature starts to fall. Why? Because the noodle loses heat to the surrounding, especially if it's, say, an air-conditioned place, or you go to a restaurant, you will lose it very, very fast. Okay. So what are the effects of heat gain and heat loss on matter? What are the effects of heat gain and heat loss? So matter can change its state when it gains heat or loses heat. This is another effect. Other than the change in temperature, matter can change state when it loses or gains heat. Let's take example of water. Now, ice water, right? Or water in a solid form, which is ice, okay, will gain heat, and when it gains sufficient heat, it will start to melt. Okay, it gains heat, it starts to melt, and it changes state to liquid water. And liquid water, when it gains sufficient heat, it will start to boil, or it evaporates into water vapor, which is a gas. Okay. Now, to reverse it, a gas can change state to liquid state. When it happens, when it loses sufficient heat in the process called condensation. You will learn this in another session under the topic of water. We will learn about condensation, melting, and so on. Right? But at this point of time, you must know that a matter can change state when there is heat gain or heat loss. When there is a heat loss, water vapor can change state from a gaseous state to a liquid state. Likewise, liquid, when it loses heat sufficiently, let's say you put in a cup of water in the freezer, after some time, it loses a lot of heat until it freezes and it turns into solid ice. Okay, so another effect of heat gain or heat loss is that matter can change its state. Now let's take a look at another example. Water gains heat and changes from a liquid to gas when heated. So you can see this example here. The heat from the sun will heat up the ocean or the sea, and it will evaporate. So there's a change of state from a liquid state to a gaseous state in the process called evaporation. Likewise, water vapor loses heat and changes back to liquid when cooled. in the process called condensation. So you can see here a can of Coca-Cola. You can see here there are many tiny water droplets around the can of Coca-Cola. Now, where do these water droplets come from? Some of you may think that this water droplet comes from inside the can of Coca-Cola, but it's not true. The water droplets come from the condensation of the water vapor in the surrounding. Okay, right? Now, let's move on to the next concept. Now, heat can expand and contract matter. So in this instance, you can see here, this is a very common experiment where, to demonstrate how heat can affect solid. So solid expand when it gains heat. Solid contracts when it loses heat. So in this experiment, you can see here, before this experiment, this device or this metal ball can go through this ring. Okay, but after heating this metal ball for some time under the hot Bunsen burner on the fire, you will notice that it will not be able to go into this ring. Okay, I'm sure some of you, your teacher have shown you this experiment when you were in primary 3 or primary 4. Any of you had the, had the experience of doing this experiment or seeing this experiment? Yes, right? Okay. Okay, another example. Liquid. Liquid can also expand and contract. Okay. A liquid expands when it gains heat. A liquid contracts when it loses heat. So take a look at this experiment here. So here, at first the water is at this level. Okay, water at this level. But after some time, when you heat up this water level will rise. So as temperature rises, the water level will also rise. So those students who are in P6, right, you have learned about the main impacts on the environment. And one of the impact of the negative effects of global warming is the rise in the sea level. So you can see, linking back to this topic of heat, when there's global warming, when there's increase in the world's temperature, okay, the sea level will gain heat and it will expand. So when the seawater expand, the water level will rise, sea level will rise, and then it will cause, a haphazard in the weather system. It causes flooding, it causes hurricane, and different kinds of weather issues. So that is one of the negative impact of global warming. Right? Now, what about gas? Can gas expand and contract just like solid and liquid? Yes. Okay, so gas expand when it gains heat, and gas contracts when it loses heat. So let's take a look at this example here. You can see here, inside this bottle, there is air. So when you put this bottle into the hot water, okay, the air inside gains heat, and you expect the balloon to increase in size, right? Why? Because the air inside the glass bottle expand, causing the balloon to be inflated. But if you put the inflated balloon into this cold water, the opposite happens. The air will contract, it will lose heat, contract, and you can see the balloon will be deflated. Okay? All right, what are some of the common application of the concept of expansion and contraction? So we can see here, there are gaps. This is a railway track. Especially in hot weather, they will have to leave gaps. Why? So that to give room or to make space for expansion during very hot weather. So if there's no room for expansion, then the metal track, the hot metal track here will be maybe dislodged or crooked, or it cause accidents to happen. Okay, likewise, this is a wire. You don't see this in Singapore, but if you go overseas, electrical wires, it has to be, there's some room for expansion and contraction. In a hot day, okay, it will be expanding, it will expand, and you can see that it is loose. In a very cold day, it will contract, and the wires here will be, the cable wire here will be tight. Okay, so you must give room for expansion and contraction during hot and cold weather. In Singapore, you don't really see the need that much, because our weather is quite, hot all year round. But if you go to different countries where there are very extreme temperature changes, in winter very cold, and in summer very warm, so you have to take into account all this expansion and contraction when when purchasing or when designing materials. Now, what about good and poor conductors of heat? So metals allow heat to flow through them easily. We call these good conductors of heat. Okay, metals are good conductors of heat. But materials like wood, plastic, rubber, and air do not allow heat to flow through easily. We call them poor conductors of heat. Okay, we call them poor conductor of heat, not insulator of heat. Insulator of heat means heat does not pass through, which is not true. As long as it is a metal, okay, heat can pass through. It's only that it's either good or poor conductor of heat. Now let's take a look at a very common example here. Right, this is a frying pan. And you can see here, the metal part here, it must be a good conductor, right? It must be made of material which is a good conductor so that you can cook your food very quickly. At the same time, the handle here must be made of material which is poor conductor of heat, right? If not, okay, you will burn your hand. So usually it is plastic, which is a very, very poor conductor of heat. Okay, all right. Okay, we have come to the end. Let's summarize what we have learned today. Now, heat is a form of energy. Heat is different from temperature. Okay, temperature, you can measure them using thermometers, and the unit of measurement is degrees Celsius. Okay, heat comes from different sources, okay, such as the sun, burning gas, burning wood, electrical appliances. Okay, and heat travels from a region of higher temperature to a region of lower temperature until they reach the same temperature. All right. Now, heat can gain or loss. Very important. Heat gain or heat loss. What happens when an object gains heat? The temperature, number one, temperature increases. A solid can change into a liquid. A liquid can change into a gas, and it causes matter to expand. When an object loses heat, what happens? Temperature decreases. Gas can change to liquid. A liquid can change to a solid, and matter will contract. Okay, so these are some of the possible effects, okay, of heat loss. Okay, heat can also pass through objects easily. We call these objects good conductors of heat. And for objects that cannot, heat cannot pass through easily, we call them poor conductors of heat. Examples: air, plastic, wood, and rubber. Good conductors of heat like metal. Okay, remember we recently learned the topic on adaptation. All right, so polar bear, right? How does polar bear adapt to the cold weather? So we know that polar bear has very thick fur, right? So this thick fur traps air, and we know that air is a poor conductor of heat. So when air is a poor conductor of heat, it is being trapped by the fur of the polar bear, and this reduces the heat loss, the body heat loss of the polar bear to the surrounding. So that is why the polar bear, they can adapt very well to to living or surviving in the very extreme cold condition in the Arctic region. In fact, many animals survive the cold Arctic region, cold temperature of the Arctic region. They are very good, which can trap air. Okay. All right. We've come to the end of today's session. So it's 9:11. Okay, a bit overshot. Okay, I will take questions. Okay, maybe I will extend the session up to 9:30. Okay. Okay, we have okay, let's see questions. Zikran, why is does metal allow heat to pass through easily but not wood easily? But why it allow heat to pass through easily? Okay. Zikran asked a question. Why is it that metal allow heat to pass through easily but not wood? We know metal is a good conductor of heat. and wood is a poor conductor of heat. So at your level, you just need to know that because metal is a good conductor and wood is a poor conductor. But why is it exactly metal allows heat to pass through? It has to do with the material of metal itself. Now, inside metal, there are many electrons made up of materials which allows heat to pass through easily. So all these things you will learn more in secondary school, right? Okay, how does heat affect molecular structure of an object? Okay, Hilman asking how does heat affect the molecular structure? Again, this is secondary school object. You don't learn about molecules until secondary school. But what you need to know that when you heat an object, it expands. Okay, so just now remember I show you under the topic of matter. For solid, the particles are very close to each other, but when you supply heat, it can change the state from solid state to a liquid state. So from a solid state to liquid state, the particles or the molecules inside actually the space becomes wider. There are more spaces, right? So that is why in the molecules or the particles of liquid, it can take up the shape of the container. Likewise for gas, it is the particles are very far from each other, so that's why it can be compressed and it does not take up the shape of the container. So likewise, when you heat up an object, so it can change state from solid state to liquid state and from liquid state to gaseous state. Are all good conductors of heat good insulators of electricity? Not good conductors of electricity. Yes, in general, if they are good conductor of heat, okay, they are also good conductors of electricity. Like gold, all metals are good conductors of heat, and they are also good conductors of electricity. Gold is one of the best conductors of electricity. But so gold is being used in some electronic devices, but it's quite expensive. It's very expensive. So Zafir asks, no, I have a question a bit about metal expansion when it's heated. Will the height expand or the length will expand? Okay, it will expand in all direction. Okay, because Zafir, you're asking whether the height or the length will expand. It will basically expand in all direction. Have you all heard about bimetallic strip? Bimetallic strip. Okay, bimetallic strip uses the concept of expansion and contraction. Okay, in some objects. Okay, I'll give you one example. Now, bimetallic strip. Bimetallic strip from the word bi. Bi means two. Okay, so bimetallic strip. Now, these two types of metal, let's say copper and steel, for example. Now, when it is heated, this bimetallic strip will curve in. Okay, will be bent. Okay, will be bent. Now, from here to here, now can you tell me why is it why is it bent? Anyone can tell me why is it bent in this manner from straight and then it is bent when it is heated? Anyone can tell me? Okay, gain heat, gain heat, of course it will expand, but why does it bend? Contracts. Okay, but you still have not explained why this bimetallic strip bends. Expanded, lose heat? No. The weather is hot? No. No, you see, if it expands, right, it would expand in straight, right? It can expand from shorter here to bigger. Okay, it can expand this way, right? It can become longer, but instead of become longer, it bends this way. Now, why is it so? Very good. Iman said they bend at a different rate. Excellent. Okay, so there are questions in the past asking you about, or they give you data about the different rate of expansion. Now, please remember that different metals or different metal expand differently. Expand and contract differently. Some metals, maybe gold, steel, copper, they expand at a different rate. So in this instance, why is it that this metal here, this bimetallic strip bends? Because this metal A expands more than metal B. Metal A expands more than metal B. So when metal A expands more than metal B, so you can see here it becomes longer than metal B, and because of that, it bends upwards in this manner. Okay? Maybe the two different expand causes the change in shape. Yeah, it is different rate of expansion. Okay? How come heat can make metal bend when it goes very rate? What do you mean by very rate? When you heat up and under very high temperature, will good conductors of heat conducts heat away quickly? Okay, so Ishra is asking if an object, a good conductor of heat, is also it will also gain and loses heat quickly, more than poor conductors of heat. Okay, it will gain and loses heat quicker than poor conductors of heat. Is electricity a form of heat? No, electricity is a totally different kind of energy. Okay, another topic under electrical energy. When you are in P5, P6, you learn the chapter on energy and you understand that energy, there are different forms. There are electrical energy, heat energy, sound energy, light energy. Okay, so electrical and heat energy are different. Okay, is wood a good conductor of or bad? Good conductor of what? Wood is generally a poor conductor of heat. Okay, okay, Shira, bye bye. All right. Okay, I will take any last question before we end this session. Any other last question? Okay, very good. Okay, thank you very much. Okay, we have